Okay, now next part. So we know what are perfect squares. So 1, 4, 9, 16, 25 are all perfect squares because they are a product of the square of the integers 1, 2, 3, 4, 5 respectively. Okay, so what does the prime factorization of a perfect square look like? Okay, we know that prime factorization means to express a number as a product of its prime factors. Okay, take note, prime factors means each of these factors must be a prime number. Okay, so let's go. So 1, how will 1 be expressed as a product of its prime factors? Okay, let's see whether 1 can even be expressed in the form of product of prime factors. Let's look. Okay, so 1 is actually 1 square, but we all know that 1 is not a prime number. So there is no prime factorization for 1, I suppose. Okay, so we don't call this prime factorization for 1. Okay, because 1 is not a prime number. Okay, so what about 4? 4 is a perfect square, and we know that 4 is actually the product of 2 square, and 2, the number 2 here guys, okay, is a prime number. So we can express it as 2 square. Okay, now what about 9? 9 is a product of 3 square, and 3 is a prime number, so we can leave it as 3 square. Now what about 16? 16. 16 originated from 4 square, but is 4 a prime number? So 4 is not a prime number because it can be divided by 2, right? It's an even number that can be divided by 2. So we have to express 16 as a product of its prime factors, which means that, let's do this guys. Do this one. Yes, do this. Okay. So 16 divided by 2, and then we get 8, 8 divided by 2, we get 4, 4 divided by 2, and so on until we finally get 1 at the bottom here. Okay. Then 16 can be expressed as 2 to the power of 4, and 2 is a prime number. So we can express 16 as 2 to the power of 4. Okay? Alright, now what about 25? 25 can be expressed as 5 square, and 5 is a prime number. Therefore, we can actually write it down as 5 square. So these numbers over here, okay, that you see, alright, they are all the prime factorization of the perfect squares 1, 4, 9, 16, and 25 respectively. Okay, so the power of each prime factor, if you notice, is actually a multiple of 2. What does it mean? There, 2, 2, 4, 2. Right? They are all divisible by 2.